All right. So should we start? Yeah. Today I'm really happy to introduce before you special guest, an expert in his subject, Professor Ulysses Sengupta, who is the Professor of Architecture and Urbanism at the Manchester School of Architecture. And he's also the founding director of Complexity Planning and Urbanism Research Laboratory, which is known as the CPU Lab. Smart and Sustainable Future Cities University Research Group, and the leader of the MARCH program. The CPU lab, I think we'll hear more from Ulysses as he speaks on. It actually talks about a conceptual complexity framework for transdisciplinary research spanning natural, social, and design sciences. This involves new digital tools, computational thinking, and theory addressing urban transformations. The research spans future cities, smart cities, IoT, agile governance, and cities as complex adaptive systems. The lab is a founding member of the Data and Cities as Complex Adaptive Systems, an international ESRC strategic network. That's all I have here. Anyway, we'll hear more from you. Ulysses previously headed advanced digital design at the Manchester School of Architecture and collaborated on the M.Tech course at the Architectural Association in London. He was a unit leader, master at the University of Nottingham for 8 years, and lecturer at the University of East London. He is also director of SopGrid Limited, which is an architecture and urban research focused, internationally networked design practice with previous work in India and China. Ulysses balances a parallel discourse between between design theory, methodological innovation, and application in practice as the subjects of architecture, urbanism, and planning. Welcome, Ulysses. We are so happy to host you, and we just visited him and got a chance to interact with him in his department, and he was gracious enough to show all the kind of research that he's been doing. Professor Parmar, the director of KRVIA, and I visited him in Manchester uh, recently, last month. And over to you now, not wasting much time.
Thank you, Binti. That's a very long introduction. I appreciate that.
You deserve every bit of it.
I'm very happy to be here. Thank you for the invitation. It's been I think it's been about 10 years since I lectured at Krivia last time, or in Mumbai. So what I've prepared for you today is a little bit of an overview that's introduces you to our work, touches on some of our earlier research in Mumbai, and then comes back to the UK, where we are doing most of our work at the moment. So hopefully, while that span means I'm going to rush through a few things, I'm happy to raise a dialogue around that at a later date. So hopefully that will work out. Let me just share my screen, and we should be able to get going on that basis. So please feel free to interrupt me while I'm talking. It's not meant to be something where you can't talk or tell me if things are not working out. Can you see that?
Yes. Yes, we can see.
Okay, perfect. So since it's been a little while, I'll give you a very quick introduction to the kind of work we do at the CPU lab here in Manchester. So the CPU lab really takes a look at things to do with how socio-technical transitions and urban transformations in cities and society can be addressed by designers using the same technologies that we're actually seeing change society. So it's not a purely critical view. It's neither technophobic, nor is it based around some kind of idea that technology will serve or solve everything. It's trying to use the new opportunities that we see in order to deal with the transformations that we're seeing in society around us. Our areas of work have spanned these specific projects. So these are not just the areas, but the projects we've been working on here recently, which are primarily to do with smart cities, Internet of Things, future mobility, and zero carbon futures. The data and complex adaptive systems, the DACAS network, is a combination of universities that we put together, but primarily the important aspect of that is that it's very interdisciplinary. So it works across engineering, economics, ecology, mathematics, physics, and that's the basis of the kind of computational modeling and approach that we take. So it's not purely about data, it's about how we model futures based on that. So some of the work we've done here in Manchester involves things to do with how we take a look at behavior change in terms of travel behavior, how we create standards across Europe for interoperability between different kinds of data-based applications, uh, connected autonomous vehicles and their operational models for actual implementation, and also at a much higher level, things to do with the sustainable development goals and the complex interrelationships between them, which we just did a workshop in TIS for a few months ago, which was about understanding the implications of working in one area versus another. So I'm going to come to the audience that I'm dealing with today, which is very much about a designer's perspective on how any of this can actually help us become better designers. And I think that that's really the focus of the discussion today. I'm going to try to get rid of this corner down there. Okay. So the primary issue that we have faced as designers is that coming through architecture school, and I'm a trained architect that practiced for many years, is that we are taught that our imagination and our abilities will help us to change the future. And we're introduced to ideas that are historic, that demonstrate the sort of heroic idea of the architect, whether we have Corbusier or Wright. So we enter the discourse on the basis that we are kind of going to make the world a better place somehow through our imagination. And then, unfortunately, if you work at the large scales that I have tended to in practice and then in research, we realize that we are actually thought of as the evil empire. So, I mean, planners coming not from a practice-based planning perspective, not from the cold face, but from a strategic perspective, have clearly indicated that architects and designers and engineers are considered to be the people who create problems rather than solve them from their perspective, because we are part of the capitalist movement and part of the free market. So we exacerbate inequalities, we make the world less sustainable, and at the end of the day, and this was possibly even more heartbreaking if we take a look at the perception of what planners, architects, and designers actually have any power over. This is a very quick indication that shows that architects are actually responsible for many things, quite often legally responsible, but in terms of the ability to change the future and to initiate that change and to empower that change, there are limitations. So maybe that's why we had to go off into a different direction to try to understand how to get into a less naive, maybe, position on trying to work with urban transformations. And we got into a systemic approach. And a systemic approach by itself is quite a historic approach. It just means trying to understand things in relation to each other, trying to define systems, which are quite a subjective definition in terms of self-similarity, structure, purpose. But the part that really, I think, drove our discussion is the idea that a system has got emergent behaviors. And this is where the idea of a mechanical or purely biological system starts to overlap with social systems. And I think that the emergent behavior is something that we really grasped onto. So to give very quick examples for people who are not familiar with systems, I'm assuming many people are. We've got systems like this, global railway systems, systems of knowledge, monetary systems, and systems are not in the real world perfect or closed systems. So they overlap, they are distinguished through various different kinds of political borders, national borders, through the definition of the system itself, and quite often through the unit of analysis or the level of observation. When we start dealing with the urban, which is our specific area of interest, then we find that systems tend to multiply and overlap, and there is no beginning and end. So it's a system of systems. Within that context, we also have got the idea of complexity. And not all systems are considered to be complex. And partly that's about the definition of systems and the historic development of systems. But for us, the idea of complexity is absolutely integral to understanding and working with cities. I'm going to use a couple of analogies to explain why, but they don't really explain the complexity of cities. So a lot of complexity theories are related to ideas of chaos and unpredictability, but they move beyond that. The idea that Lorenz introduced, which is somewhat misquoted as the butterfly effect, where one small change can have a large impact on another part of the world, is actually something that is intrinsic to the idea of complexity, that the scale of intervention or the scale of change in one part of the system is not directly related in terms of the scale of change in another or to the system overall. And when we think of these physical systems in the first place, then the idea of energy within the system is also an interesting analogy, because if we take a look at Bernard cells, which is the idea of a heated fluid or liquid that creates different kinds of patterns and forms that can be seen to be stable, but only as long as the amount of energy introduced within it is continuous and continues to exist and drive that structure. Then we begin to understand an analogy of cities, because almost everything that has got a physical presence follows the second law of thermodynamics and begins to deteriorate or begins to break down. So the idea of cities and the ability to maintain structures or to grow them, even to maintain them, is dependent on continuous input and energy rather than on it being a one-time thing. There are several theories that allow us to enter this discussion at a more, let's say, less abstract level. And part of these theories are to do with things like this, which is the urban metabolism model, which takes a look at flows of materials, energy, goods into cities, the metabolization, and this comes from obviously a biological perspective, the metabolization, and then the idea that there's waste, and that the idea of the circular economy actually fits within that city in terms of minimizing those wastes. They actually work together, which is not often discussed. Our particular perspective really spans these natural science approaches and ecological approaches with the socio-economic approaches that we run into in terms of planning. So the idea that policy and governance play a significant role, and we are loosely calling it top-down, while there's many bottom-up processes that lead to processes of emergence and agency, and how they interact in the middle in this spatialized context for us as architects and designers is of primary importance. So that's in multiple scales, from infrastructure down to individual dwellings. The idea of resilience continues to be one of our driving theoretical touch points, but resilience is often stated in a political context or an economic context as the engineering concept. If we take a look at Holland's distinction between the two, we take a look at the engineering concept on the left, which is about maintaining a particular system or trying to get it to return to its original state after shocks, while the ecological one is about being able to transition and understand these threshold moments so that we are working on the basis of multiple states of a system that are possible as functional states. I'm going to dive into the idea of time and data for just a quick introduction. And time and data are things that we have been using increasingly as the basis of understanding space and its use, but also predictability in terms of behavior within space. So this is a very quick example of us trying to understand what happens in our own campus, or at least a part of that campus on a weekly basis, tracing movements through ping data, which is collected from mobile phones and laptops anonymously, to understand how people use the library, how people use open spaces, etc. This kind of data-based analysis can also be used predictively to some degree. So some of my master's students are asked to experiment with these processes, and one of them came up with this algorithm which is used to predict the success of movies on their first weekend of opening, and used it to try and predict when people turn on their heating in Manchester, which is obviously cold. We had the actual gas um, heating data to compare it to. And what we were able to do is to use Twitter feeds, so an informal um, basis of social data, to try to understand whether we could predict when people turned on their heating in Manchester, their gas heating specifically. And it was interesting because we found that we could actually use the algorithm to predict based on words used in tweets about it being cold or about needing to turn on heating, etc., to high degree of accuracy whether people were actually going to be turning on their gas heating. Interestingly, when they turned it off was not as predictable because people don't tend to tweet about turning things off, or maybe there's a psychological element which is not something we are experts on, to do with shall I keep the heating on the basis of it might be cold again tomorrow. So there are different aspects and elements when you work in this sort of interdisciplinary area where you have to be able to understand the limitations of the process you use, but also it gives you insights into some of these areas of further inquiry. So this is an interesting piece of work done by one of my current researchers, which takes a look at Airbnb data, which you're familiar with, but also Zoopla data, which is a property sale price or rental price. And the area that we're looking at is the Manchester corridor, which is the area around the University of Manchester, Manchester Metropolitan University. And what we're seeing is that Airbnb and its increase has driven price and rental price higher and higher over the years. And this has resulted in a crisis in terms of student affordability. This is something that has become recognized in different parts of the world. So there's been regulation, if I remember correctly off the top of my head, in places like Vancouver, etc., which tries to regulate the amount of Airbnb use in particular zones, because it results in this kind of future impact. Now, coming back to the idea of us not just being people who analyze the urban, but who try to change futures. We are designers, despite my starting point where we are sort of part of the evil empire. Our aim really is to change the future. So we work on the basis of this. This is a very old diagram for us, which we worked with students for years, which is the idea that we need to understand the issues and their historic development in order to be able to intervene in the present, but with an eye towards what that impact of that intervention will be towards desirable futures. And we've developed processes which we have published, which try to formalize some of those developments. So you can see the top half of this diagram is really about going through a significant data collection process to actually understand. So it's urban studies in effect, to actually understand problems and to formulate the problem, which is something that I believe is highly neglected in our current design education. So problem structuration, simulation of what is actually going on, and then the idea of intervention, so that it's not just vision based, but it's based on current trajectories of change within which we intervene, and then moving into the design resolution towards implementation, towards the bottom of that diagram. We do deal with time horizons in various ways. One of them, and not limited to this, is the cone of plausibility, or the futures cone, which we have redrawn here, because in complexity terms, there's the idea of short-term higher predictability, longer term being more exploratory, the idea of plausible, probable, and possible futures, and within that, how you try to influence the conditions that can lead to more desirable outcomes compared to less desirable ones. So obviously we are in the age of the climate emergency, and within that context, a large amount of the discussion around sustainability has primarily been socioeconomic. And we think that we need to tie those two aspects together very strongly. So we've started to experiment with ideas where we are taking a look not just at embodied energy and carbon, which is something that is quite mainstream now, at least in the UK, for architecture and the built environment, but also in terms of occupational or in-use operational energy and carbon as we look at the future and future changes. This is less easily quantifiable, but is worthwhile study, in our opinion. I'm going to talk about a couple of research/design projects. So I'm going to touch on some of our early work in China, then in India, and then come to Manchester on the basis that it might actually allow a more accessible, less purely theoretical discussion and some exposure to the work. So one of the first parts of the world where we undertook this kind of research was in Jindojin in China, which was a city that was going to be connected to Beijing and Shanghai at the time with high-speed rail, and so was about to undergo significant urban transformation. And what we're seeing here is the historic city center on the right-hand side of that river. And the historic city center, Jindojin is the city where the porcelain kilns, the royal porcelain kilns were, and so what we see here is the porcelain city is currently, at the time of the study, thought of as a historic city which could be erased and replaced with a tourist-orientated destination. And our take on that was really that erosion and replacement of large tracts of urban morphology was problematic in various ways that we know of, including, gentrification, etc., but also in terms of the ambition of the city to actually attract people to a city that is famous for its porcelain production, the idea of the values being in contradiction if you actually erase what you're trying to value. So we took a look at the studies that had already been done of the area and added our own in terms of the historic relevance of particular aspects, the date of the buildings, the actual type of morphology, the proximities. But then we wanted to understand how the territory could change through process of emergence, which is directly related to complexity. So what we did was we went there and we started to observe what spaces were used for. And this was an organic in a loose term, so historically developed city without formal planning in that historical city center. So, or at least modern formal planning. And what we started to find was basically about uses and uses of space, socioeconomic activities related to types of space. And then upon looking hard enough and long enough, we began to see these patterns emerge that related to each other. And really, the idea of emergence and idea of observability for us is related to patterns, because patterns can be spatial, patterns can be social, patterns can be temporal, they can be economic. And bringing these ideas together allows us access to things that can be understood in relation to each other systematically. So we started developing these models that were bringing in different types of data. Some of that data is data as we understand it now, but a lot of that data was really ethnographic research on the ground, interviews, dealing with observation over time. Bringing that together with urban form, bringing it together with the current residential strategy, from the city, the planning strategy, the idea of reuse, the idea of conservation, the idea of replacement, and trying to understand it as a process which some people would call it sort of a pointillistic approach, but really we were trying to take a look at how change was possible rather than conservation only, but not in a way that replaced the socio-cultural identity. So for us, the most important aspect of that was to understand the logic of self-organization that was actually already existing in the place. And what we've got here is a model that takes a look at bringing together all those different types of informal buildings and formal buildings and empty spaces and squares and activities from tea shops, etc., to understand how they developed over time, why these forms, how does a new settlement fit into the existing. And what we're going through here is a stochastic search process that uses two different approaches, the Monte Carlo and Brownian method, to try to repopulate the area within the larger street patterns so that we're able to simulate how it might have developed over time. So having studied how these dwellings actually formed and what kind of shapes they have and what kind of activities take place, we try to recreate that in a sped up process so that we could understand how the system changes over time in order to be able to try and intervene within it in smaller ways that leads to transformations over time rather than as an erase and replace strategy. So some of that, and this is a different part of the city, was related to understanding existing morphologies, existing syntax, patterns in the city, and then applying it to other parts of the city which were going to be developed rather than just the historic center. So this is the part of the city that is to the west, which was going to be redeveloped, but the redevelopment would have been ignoring the existing cultural and spatial conditions of the city. And what we did was we took ideas of proximity of different activities, why one thing wanted to belong next to another, how these parts fit together in terms of vertical striation. And the idea is never to come up with one singular optimized master plan, because that would be in complete contradiction to our understanding of all urban territories as transforming and fluctuating territories. But the idea was to come up with something that was a model that could be continuously added to so that we could understand change and how intervention within that change might actually allow the city and the people living in the city to work towards aligning the values that currently exist and that were aimed for. So it's basically a series of open-ended processes where continuous updating could be introduced to see if the alignment was going away from where both the residents and the policymakers wanted it to go and where they met or didn't meet. I didn't want to spend too much time on that project because it was just an introduction to the way we began to work. I'm going to touch on our work in Mumbai. This was also several years ago, and it was before the Bandra Kurla complex was fully developed. So you can imagine that there's been quite a few changes. But when we came and we did a little bit of work with Krivya, who introduced us to some of the territories and some of the history, we started to try to understand Mumbai in terms of these morphologies and in terms of these flux territories, as we call them. And Mumbai is an even more extreme case than we studied in China, right? The overlaps of the different kinds of formal and informal territories is absolutely extreme. And we took a long time trying to understand how to actually work with them, how to actually try to model them, how to actually try to get our heads around that. And a lot of that was about stopping the idea of coming in with preconceived notions of what it should be. and trying to react to urban conditions as moments in fluctuating field. So right at the beginning, so these are just experiments that we were undertaking to try to understand the types of self-organization in Mumbai. We developed a series of exploratory models that combined analog and digital processes where agents reflecting developments, people, etc. Agents can be anything in a computer model, were attracted to particular functions, were repelled by particular functions, were attracted to each other, were repelled from each other, informal, formal, particular functions, particular infrastructures, and started to try to understand how the overlaps and the tensions between these different systems had developed over time. And we started making these models more and more, I won't call it complex yet, but more and more nuanced in terms of how many factors started to interact with each other until we get to the point where we have got an ability to understand based on observation in Mumbai what kinds of functions are attracted to what kinds of infrastructure, what kinds of uh, developments repel other developments, um, and so on. So we were taking a look at both Navi Mumbai and Mumbai at the time. So we're taking a look at train infrastructures, road infrastructures, uh, existing ports, the mill lands at the time as well, urban to rural, rural to urban migration, and so on. Now, I wanted to finish here. And we began to try to understand how the pressures of one system on another or the overlaps were actually intertwined through these experiments. Part of being able to work with Mumbai, as you know, this is us coming in as outsiders, admittedly, was to try to understand the morphology itself and the spatial types. We call them types because we work with genotypes and phenotypes in our modeling. And the idea of being able to categorize these types so that we can understand them as genotypes then have the possibility to become various different applied types when it comes to particular situations, so adapting to particular conditions. And we took a look not just at building forms, but the spaces in between them, just like in China, and the relationship between objects, internal and external functions. An additional factor that we decided, because of a lack of language barrier for us compared to China, was the fact that we started to talk a lot more to the people who were actually living and working and using these spaces. And quite a lot of the time, we had to readjust our understanding that came in from an outside perspective in terms of site accessibility, in terms of meaning, in terms of importance of spaces, because the perception of these spaces wasn't ours. It didn't belong to us. It belonged to the people who actually use them. And different groups had different perceptions of the same condition or the same space. So the process involved a series of interviews, a series of observations, etc., in a much more in-depth way than we had worked with previously. And it was useful to work with Krivya at the time to understand the processes that were going on in places like Dharavi and so on. And what we came up with was a series of models that explored how different kinds of informal settlements, so the most self-organized of the city, actually emerged over time, and what were the intrinsic rules of these settlements. What were the rules of how many dwellings in a row do you build up against the wall of another? How many floors can you build up on based on the type of structure you have? How do these internal routes and pathways actually remain retained? And what were the relationships between the different functions within these informal developments? What was the relationship between a mosque and a school and a medical center and a shop? And how is it that shops were either clustered or equidistant from each other if they had different kinds of functionality. So all of these became modeled by us. And the process that you're seeing here is really trying to understand the modeling in terms of distance from each other, clustering, reaction to particular infrastructures such as pathways and streets. And what we do is we build these models so we can adjust them. So they're never predictive in that sense. So we can experiment and explore with them and try to say, well, what if it's this kind of pattern? What if it's this one? Does that more clearly reflect the specific condition we're looking at? What if we were to change the proximity or attraction between different functions? So all of our models are based on the idea that there is a designer or a stakeholder able to manipulate the actual parameters with which we are working rather than it being a purely predictive one based on statistics, etc. But sometimes when we work with simulation of urban territories, we get asked this question, right? So why? Why do you need to simulate? Why can't you just come up with visions? Why can't you come up with where you want to get to? And really, that comes back to a question of how design and intervention in the city has been vision based for many, many, many years. And the idea that a more nuanced understanding of what socio-cultural spatial issues are and how they change over time might lead to better outcomes than the ones we have seen, which have got failures due to various reasons, not just their spatial configuration, but various reasons that don't take into account the overlapping systemic and emergent effects that we see in these urban territories, which are very complex. So we don't want to repeat the mistakes we've had before. Part of this discussion about simulation is not just about simulating what is already there and the processes of change. It's also about being able to intervene. So intervention really from the bottom up through small, tiny changes that can result in larger changes to pattern is one option. The other is actually to jump into the level of pattern itself. So you can jump in at different scales. And what we've got here is obviously the Docklands, which you're more than familiar with, and the idea of the development of the Docklands, attacked in terms of design based on the understanding of what patterns mean on the ground. So once again, a series of studies which allowed us to at least get some idea of what was going on the ground rather than just taking a look at things from far away. We did get chased out of the Docklands many times, I might say. But trying to understand patterns, not just for the sake of patterns in a sort of mathematical way, but in terms of socio-spatial cultural implications in a particular condition, in a particular context. And then being able to understand those patterns so that we can think about, so what would a new pattern mean? So if we've got patterns that are historic or less formal, and if we've got patterns that are more formal because of other functions or because they're being implemented now, what would a new pattern that is something that is in between the two, a bridging pattern, mean? Would it work, right? And we started developing models that allowed us to generate different kinds of patterns based on research into how formal versus informal patterns actually differed from each other in terms of urban morphology. So the idea that we could actually create patterns on the basis of understanding what the geometries were, what the scales were, but also in terms of being able to merge a more formal versus less formal morphology. So you could go in between them. And most of our models are algorithmic rather than purely mathematical. So they're based on logic and reevaluation. And what we were able to do was to try to explore what those different conditions were in informal and more formal situations, and then try to implement them into new patterns that could be understood as hybrid patterns through evaluation and algorithmic methods, so that we could then come back to, so what do those hybrid patterns actually mean do they already exist? Do they give rise to new conditions? Are those new conditions potentially favorable? Do they actually deal with any of these issues? And I'm going to get into the work we've been doing in Manchester, which deals more directly with future cities in a minute. So you'll see how we actually deal with trying to drive those factors and understand them in the future. So the last part of my presentation really is about future territories rather than flux territories. So a lot of the work in Manchester, which is a much more formal context, while it still has bottom up and top down factors, is about technological transformation, implementation of new infrastructures, or planning drivers that are based on economic factors to regenerate parts of the city. And we've been working for years with the strategic planners to try to explore where those future scenarios would be beneficial versus detrimental. A lot of our work in Manchester deals with development and the possibilities of development. So we come up with various different kinds of generative models that take a look at how development would occur on the basis of underlying factors related to proximities, to economic drivers, to proximity to transport hubs, etc. For us, the evaluation of these generated territories is really important. So it's not just a picture that you produce at the end of a design process, but you produce something that is a digital model, a digital twin, some people like to call it nowadays, where you're able to evaluate certain things. So in this context, I'm demonstrating a student model which evaluates urban accessibility through walkability, right? So access to your local school, access to your local commercial opportunities, really access to points of socioeconomic activity on the basis of not having to take motorized transport. These kinds of models can be expanded to take a look at walkability, to take a look at how you change more the actual built form to enable more walkabilities. It's attempting to be more sophisticated than a purely geometric analysis through sort of a space syntax only method. It's trying to take a look at how the morphology plays a direct role on aspects. It goes beyond the idea of drawing circles on a plan, for example, trying to understand how the different functions act and different footprints and different scales and infrastructures interact together. So I'm going to keep this moving forward so that because they're just little bits of demonstration, but we do take into account a feedback loop between these types of analysis of accessibility, analysis of access, analysis of overshadowing, analysis of energy use, and the actual form that is being tested in different scenarios. So this is actually not a linear process, but an iterative one. A big part of our work at the moment is related to urban mobility, and that's strongly related to both urban form and to the idea of zero carbon cities for us. Because obviously we're aware that energy and emissions are directly related not just to the built form, but also to having to move around it. So what we've done is we've developed an area of AI, which is intelligent computational agents, so agent-based modeling or multi-agent systems, which allows us to try to take a look at designed future scenarios of cities. So there's a designed future scenario where we have got physical assets, we've got agents which can represent mobility, transport, but also people with different conditions, with different requirements, with different biases, with different needs for where they need to live, and be able to analyze the scenarios that we produce in terms of how they meet or do not meet particular values. And these values can be top down and bottom up. So values of the citizens needing to go about their daily activities, values of policymakers trying to reduce emissions, values of trying to move people away from motorized personal transport towards public transport, etc. And they're based on quite a sophisticated, not purely rational agent approach. So historically, these kinds of models were all based on rational agents. Everybody needs to go to work, to school, and come back, and everybody has the same bias. But our agents are a little bit more sophisticated. We're experimenting with cognitive agents and with the idea that different agents actually have different profiles and needs and decision-making processes. And that's where the AI aspect comes in. So we bring the urban future scenarios together with these different kinds of agents to try and test what that actually means. The point of it is to test these future scenarios. So jumping into another project, the historic way of thinking about, or the public transport way of thinking about uh, transport planning is really about accessibility to transport and being able to deal with whether a particular new line would meet the needs, so it's predict and provide needs of a particular population. What we bring to that through these different kinds of agent-based models is an ability to test a less rational set of choices. So, for example, we could bring a complexity perspective in which people who use public transport make their initial choices on the basis of time, cost, reliability. But then if there's a problem on the journey, if there's congestion, if there's something of the sort, then what happens is that they can change their decisions and they can actually choose to go back, to continue their journey, to change their mode of travel. This is Greater Manchester with a GTFS, so schedule-based urban transport system, public transport system. And the red dots that you see are the waiting times at each of the interchanges from bus stops to tram stops, etc., where people are waiting and then making a decision. So agents, as people in this simulation, are changing their minds, continuing their journeys. And this allows us a more sophisticated understanding of the actual use and congestions, and it puts up discussions about a system optimal versus individual decisions. So part of that then has to become reality because this is all abstract and it lives on a computer. So we're testing scenarios based on slightly more intelligent approaches. But then behavior change on the ground has to be enabled through knowledge. So we also do things like develop applications that allow people to make journey choices, not just on the basis of speed or cost, but on the basis of lower emissions, on the basis of a more active journey, on the basis depending on what their time and preference is. So on a weekend, somebody might be able to leave efficiency aside and make a choice that is different from going on a Google Journey Planner. So this is a prototype that was developed as part of one of our projects. I'm just keeping an eye on the time at the moment. So I'll talk about one more project, and this is really about future services. So operational research into emerging technologies. And this project is about connected autonomous vehicles, and we worked on a research project in Manchester. And the research project was about what would, and this is becoming a reality, so what would autonomous vehicles and connected autonomous vehicles being a kind of UK angle on that mean in terms of future use and infrastructure for mobility in Manchester. So what we did was we decided that we would test the idea of connected autonomous vehicles in competition with existing black cabs, so taxis, in a ecological competition model. In this case, the competition is for riders, for customers going from Manchester Airport to the city centre. And we modeled everything from every single person based on statistics of how many people come through the airport, different terminals, different vehicles, different behaviors for taxis, where they wait, how often they come, whether you have to call them, where they pick up from, versus connected autonomous vehicles, which have more collective behavior. They can communicate with each other, and they also work on the basis of not just picking up individuals, but waiting for part of the vehicle to become full. And we were able to estimate emissions per passenger, distance traveled, deadhead travel, so empty travel, etc. And we're able to design a future operational model that would actually perform better than black cabs if we take into account the fact that there are different value sets against which this has to be evaluated. So the different value sets are important because not everybody is assessing these operational models against the same desirable outcomes. To give you an example, so if we take a look at the left side, which is taxis, and the right side, which is connected autonomous vehicles, operator interests are the interests of, in the taxi context, taxi drivers and the companies that own these taxis, or and so on. And the city interests are primarily to do with lowering emissions and use of energy. And the user interests are the customers or the passengers. And you can see it's possible to design an operational model which advantages the user and city interest in comparison to existing operation of black cabs, which are primarily based around operator interests. So being able to develop these for us has been crucial in informing a lot of strategic policy. So we work with Transport for Greater Manchester and also with strategic planning in Greater Manchester. And the primary area of our models influencing the future has been around strategic policy, so that the policymakers are able to understand the implications of pushing certain parameters versus others and building them in or de-risking certain scenarios. And I'm going to finish pretty much on this. So some of our student work, and we've been pushing the idea of zero carbon cities and not net zero, which is used interchangeably, because net zero means that you're allowed to offset. So trying to solve zero carbon cities on site, developing future scenarios through the kind of generative modeling that we have, but then analyzing those future scenarios. This is East Manchester or North Manchester, I'm trying to remember, North Manchester, and trying to analyze it against multi-criteria analysis. So the multi-criteria analysis goes from how many units, amount of commercial area, plot coverage, so density, solar irradiation, so potential to generate electricity through solar, annual electricity consumption, and so on. Public service area, access to green amenity. So multi-criteria analysis against each of our future scenarios allows us to begin to understand that there is no one perfect optimal solution, but it is really about understanding the values of the stakeholders, and the stakeholders are not just the policymakers here, and being able to find the best possible option in terms of what would move in the right direction as opposed to towards undesirable future outcomes. And so we finish with this, which is our process in terms of how we bring in various different kinds of input into a generative design process, come up with different future scenarios as the outputs, have got a multi-criteria analysis and data evaluation process, which we score. All of this is informed by the values of stakeholders in our urban transformation process. And at the moment, there's AI in 3 different areas for us within the loop. So in the large feedback loop, which is about the cognitive process of those scores, to reinform what we should actually be modeling and understanding, and then within the generative process and within the data evaluation process. So I'm going to stop there, if that's okay, and drop out of the presentation. I'm happy to take questions. So I tried to stay on time, Binti.
Thank you, Ulysses. That was fantastic. I mean, I have been taking my notes diligently, and I will take time to process all that information. But yes, uh, just to start off a conversation, it's very interesting that how you have introduced all these sophisticated tools of simulation and digital analog and to understand the bottoms up approach and to make it more user friendly and to facilitate what we call as the people's approach to planning. So I was just a little intrigued by the fact that given my limitations on the usage of such sophisticated technologies and being an ethnographer myself, how do you think I could be of any use to this kind of research that you are undertaking right now?
Sure. So the the fact that we are so interdisciplinary means that we don't cover all the areas that we need to. I mean, the urban is everything, right? Um, maybe not everything, but every aspect in terms of disciplinary aspects. And we are not able to cover all these aspects in depth, which is why we work with so many different other disciplinary experts. So ethnographic research, social science, etc., play a crucial role in being able to bring in perspectives about what's happening on the ground and those bottom-up processes. So we tend to spend the majority of our time in trying to bring the understood aspects and relationships into a model so that we can use it for design processes. But the research on the ground is something that we typically don't have as much time for. So, if they don't have a dialogue with each other, what are we modeling? I think it's
So, I mean, there is a chance that I can be employed in your kind of research.
there, there absolutely is, and a lot of our projects, as I said, we were working with TIS recently, so a lot of our projects are about working with people who actually come from perspectives that are very much about not just design, but about understanding what is going on, and I think that is crucial.
Yes.
Very, very true. Complexity of cultures and civilization, each interaction. This is what I was about to ask you. How do you get cultures, communications, communicate with each other so that, see, it's very easy to talk about urbanization and tall cities and all this. Somebody sent me a picture of a one single floor, some 1890, 300 floors high or something, pencil tower or something. I was amazed at technology, but technology can infuse art to make human life much more compassionate, much more livable.
Yeah. So that's exactly right, and I think that the when we started doing the work, when we started on this trajectory of trying to use technology in design processes, what was popular was things like parametric design and so on, which were very much about a kind of still a heroic sort of artistic, self-driven vision. And what we realized was that the context we were working in, these were small niche projects that were potentially, a high-end cultural project or something of the sort, but they didn't deal with the actual transformation for society. And so that's where the idea of trying to actually engage with these transformations comes from. And they are very specific. We constantly get asked if we have developed a generic model that can be applied to a new situation, and the answer is no. We need to go into each condition and situation with a sort of a methodology, but then we have to work very specifically in those conditions.
Very true. Namaskars. Wonderful.
Any questions from the audience? Our master students have joined in, and yeah, so maybe some of you can switch on your cameras and start an interaction, start a conversation.
I'm happy to take any questions. There's no silly questions. I'm an educator myself, so.
Yeah, sometimes we are just afraid that the question is not intelligent enough, but then this is a lot for us to process. But we understand that Mumbai, how you have chosen Mumbai and China as these laboratories for the complexity framework, because they are so complex. And as many people have written that Mumbai is a polycentric city, and I think a lot have been written about it. So I was just curious to know the government's program on smart city mission in India, and how does it? I mean, I also have a book on it, but my book is about it's a question mark, because smart city in India, urban laboratory, trajectory, or paradigm, it's a question mark. Precisely because even I have not been able to figure it out. So I really want that we should take it forward to understand, because this government is very much into digitalization and providing the digital infrastructure, bringing governance to the doorstep of the citizen. All of that is very clear. We also understand that there is a lot of prioritization on traffic, mobility systems, safety, security, and all of that. And lots of investment going there. And then there is a lot of investment going into integrated command and control centers and dashboard governance. Cities run on real-time data and all of that. I was just curious to know that again we are falling in the trap of the top down. So I don't know, how do you reconcile the two?
Can I add one more point to this? I recently learned, you talked about China and various Southeast Asian countries. This is about floating cities and getting the cities moving from ocean to ocean and then even to the moon. I mean, it looks fascinating. Maybe it's possible, but how will that solve any human ability, etc.?
That will definitely solve some of the problems of the earth right now.
I think that the questions are related in a way, because the issue that you brought up about smart cities, we're at this point, we're all sort of aware of the history of development of Songdo, of Rio, and the IBM model, and the including the dangers of over surveillance and the impact on particular aspects of society. I think that the issue in terms of, okay, well, first of all, as people who design space primarily with integrated services, I think that there's a need to recognize that there are clear limitations to how much we are intervening within that technological process of change. And while we work on European projects to do with internet, IoT, data standards, etc., there's still a limitation. As I said at the beginning, we're not neither technophobic nor technocentric. So the idea really is, when you bring in a socio-technical transformation or any kind of emerging technology, who is actually evaluating the values against which that's being implemented? And I think if that discussion is not happening, then it's obviously not happening for a reason. Right?
Oh gosh.
So I think that that's where the primary the dialogue needs to start. So what are the values that we're trying to achieve? Because you can't say let's just preserve everything the way it is. It doesn't work. There are problems now.
Very true.
Towards what outcome? And I think that if we don't take that sort of that perspective, that if things just go along without us intervening, they might end up somewhere where we don't want, and it's quite likely, for example, with climate change, etc. And then there's also the socioeconomic disparities, which is also going in that direction, right? So if we want to intervene towards potentially more desirable outcomes, there's a huge amount of work to be done that is not just from the role of a designer, but is a much broader dialogue with activism, etc., about bringing the right stakeholders on to empower, to create agency, but then to not negate the design process within that, right? Because I don't think they're mutually exclusive. And that's what's happened, in my opinion, sometimes, where because of the sort of, that's why I started with the heroic designer and the downfall, because there's been a sort of reaction to, designers and engineers just want to be naive and make things faster and more efficient. I don't think that's true. I don't think that we need to be that naive, but I think that not bringing the designer in also results in another problem. So I'm not sure that answers your question directly, but I think it's about those values.
If it answers, then there is something happening beyond philosophy, beyond something. The fact there is a direction that can be taken towards it, because people are talking about undersea, on the moon, in space, then joining up 100 ships together and making a floating city. I mean, phenomenal imagination going on, very realistic. But will the world integrate into one nation or multiple nations of different political
Towards what purpose? Towards what purpose, I think, is a useful question.
Oh, thank you. Wonderful.
We have to think about as a society. That is a question that we as a society have to collectively think about. As a society, which I mean the government, the civil society, academia, industry experts, and of course the people. So yeah, but sometimes values are not universal values. So that is there is
so
the
as
problem.
Agreed, and as I said, for me it's an interesting area for a dialogue, because I think that sometimes. So I'll give you an example from Mumbai, right? Which really struck a chord with me, and this is from many years ago. Obviously, this is to do with the Milllands, right? And the idea that originally I could have misunderstood, but originally the idea of how space would be redeveloped and used and given over to the public in the Milllands was based around a certain percentage of that space being handed back or being redeveloped for on-site resettlement and so on. But then a little change in phrase from, the overall area to the open area or something of the sort, correct? Resulting
Open.
in
The
it
word
suddenly
open
becoming
was,
just 2% or 1 point something. And I think that,
yes.
Values, when they are described without a physical, spatial, tangible aspect, can be manipulated sometimes a little too easily. And so once again, I think that there's a role for the people who deal with the actual physicality of these things, rather than it being something that is just dealt with in terms of, say, economic policy or policies like that. And I think that that's where the values, even if they are aimed in the right direction, can be misappropriated.
Very true. Especially from the Mill Owners Association that's been going on, what to do with that land, what to do with that area. It's, I mean.
And also a more tangible thing could be, the public value of any project. What is the what is the public value of any smart city project, for that matter, or any infrastructure project, for that matter?
Yes.
If that could be spelled out in quantitative terms, then I think we could minimize most of the conflicts between interest groups.
I think,
and
where a lot of these evaluative frameworks that are coming up. So, for example, when I was talking quite lightly about urban accessibility, but if you think about it, it has multiple dimensions. So it's can I take my children to school and go to work? So these aspects, and it's not purely quantitative, right? Because there's so many, if it's not just walkability, if I have to get on a bus, then it depends on temporal services and whether it's crowded or not. And these things become quite complicated and complex. But I think that there are ways to actually think about them in design, which have been. So I also have a bugbear about design, which is that a lot of design that I have been involved in historically in practice was very much on the basis of I have to sell something that looks good, right? And that's why I moved away from that. And then, when you sell something that looks good, it's on the basis that you really just reinforce well-known principles of design because that's what's acceptable. And I understand that perspective because you in a commercial practice you have got employees and so on and so forth, and that's life. But I think that's these we're in an emergency situation, and I think that we do have to have a shifted perspective on this, and it's not just going to come from one aspect, right? So I think that is important.
All right. Let's see. I don't see any questions. Are there any?
I apologize if it was a little too complicated. I did try to give you an overview.
No, I mean, we will call you for a sequel to this lecture so that, one by one, you tell us what is a flux and what is a butterfly effect, what is embodied energy, what is, yeah, analog and digital processes. So, and of course, the organic emergence, the emergence and observationality related to patterns. So that is quite interesting. I mean, each of these keywords, could be a series of lectures. So I think one lecture is just not enough. This was an introduction. It was fantastic. And I think we will continue this conversation. And next time you are in Mumbai, I would like you to conduct an entire week-long elective.
Wow.
So that we
Wow.
do justice to all of these, and one by one, in micro kind of blocks, modules, we understand whatever you have, and on all the plethora of examples that you have given, Mumbai, China, and also in Manchester. And I believe you're also advising the government of the local government in Manchester in some of their planning programs. Could you just share a few examples?
I can bring more examples from here. I just had a note from somebody saying that there are potentially some questions in the chat.
Okay, let me just see that. Okay, there could be. Can you see some questions? Because
So I can see Shalini Dutt saying, are you looking at environmental design, passive or active, as part of these urban informatics and analysis exercises? So the shorter answer to that is, when we took a look at zero carbon cities or zero carbon future cities, we realized that a purely passive approach, so without any kind of energy generation, was not viable, right? So that's why we're not anti-technology. The idea that energy generation, etc., and active technologies can play a role shouldn't be discounted. It's, as I said, it's just about two words, what. And I think that that's important to keep in mind. There are obviously issues to do with these technologies in terms of global chains, in terms of e-waste. So once again, a systemic perspective is something that we bring to that discussion. And I mean, if you Google my name, you'll probably find articles that come from both sides. One saying, it's good, one saying it's bad. But
because waste becomes wealth, wealth becomes waste. Very true. You never know to which context.
Correct. So I think those perspectives are, being a little bit more informed about these chains and supply chains, and then as I pointed to the models which take a look at how these processes can be circular or not circular, etc., are all part of that discussion, I think.
True.
So I think that's the only question that there was actually in there.
People are a little fatigued right now because it's 3 o'clock and it's 4-ish, 4:30, and yeah, they had a long day and they feel a little sluggish.
I understand.
Yeah, maybe they'll email you. I'll share the email ID with people, whoever is interested, and they can come back to you with questions in the future.
Sure, not a
Thank
problem
you,
at all.
Ulysses. Thank you once again for accepting our invitation and for your time and for sharing your knowledge and your research with us. I'm sure we will take time to process all of this. We have recorded the lecture. We are going to upload it in the social media so that it's shared with everyone, and we'll come back to you. I'm sure. Yes.
Thank you again for the invitation. I look forward to continuing the dialogue.
Thank you. Thanks.
Bye-bye for now.
Bye.